Pythagoras' theorem extension. So we need to be able to find the value of a shorter side with Pythagoras' theorem, and it's really just substituting the values into the equation and solving for our shorter side. We will use exact form for these, which says that if our square root wouldn't give us a whole number, that we should leave it in the form of a square root rather than evaluating and rounding and losing exactness there. So we always write our formula, substitute in our values, and of course we need to get b squared on its own. So we will be subtracting 16 squared from both sides. So b squared is 30 squared minus 16 squared, and I have of course flipped the sides there as well to get b over here. So b, grab our calculator at that point. $644. Sorry, that's b squared. B is the square root of 644. And if we do the square root of 644, you'll see that it actually leaves it in exact form for you. We haven't learnt to simplify surds yet. It's an interesting thing if you want to Google, have a look at it, or ask your teacher. In Year 9, you'd be okay to leave it as this, okay to leave it at that, but what we don't want is to get this horrible big decimal and round it and thus lose some of the accuracy of our answer. Because if we have to use this value in another question, we want it to be as accurate as possible. And if you're interested, sorry, that's a 2, in simplifying surds, do check that out. So it's exactly the same as finding the hypotenuse, just make sure, of course, that you rearrange your equation. Now you're welcome to give these a try without watching my example, and then check the video to see how you did. If you didn't get it or if you can't manage it, watch me working it through. Find the value of x as an exact value, and I've got an isosceles triangle here. Start with Pythagoras' theorem. Incidentally, a lot of textbooks will offer you rearranged versions of this, but anytime it's an even slightly tricky question, come back to the main form of Pythagoras' theorem. Because of course here a and b are both x, so this says that I have 9 equals 2 lots of x squared. Divide both sides by 2, we might flip this as well to get x squared equals 9 over 2. Leave it as a fraction. It's almost never worth your while dividing out. You'll just have to use your calculator somewhere along the way. We want the square root of this, and when you're taking the square root of a fraction, do remember it's the square root of the whole fraction. But, and again, this is about arithmetic with surds, which we haven't really covered. The square root of a fraction is the same as the square root of the numerator over the square root of the denominator, and you can see that root 9 is 3, so we could take this to 3 over root 2. In Year 9, of course, I'd accept you leaving it like this, that's just fine. If you tried to evaluate that, you'd get a decimal, you'd have to round, and we wouldn't have an exact answer anymore. And another, find the value of x as an exact answer. And here we've got 2 different values, but still represented in terms of x. Write your formula. Do feel free to give this a try, and then come back to see how you did. Now, do remember that when I square 3x, that will have to be in brackets 3x squared. And when I expand that, if you remember your index laws from Year 8, that's 3 squared and x squared. We're squaring everything in this term. So I have 49 equals 9x squared plus x squared, so 49 equals 10x squared. Again, we'll get our x squared to this side, and that will be 49 divided by 10. Keep it as a fraction. Don't go simplifying. Definitely don't make that into a decimal. So x is the square root of 49 over 10. And remembering the last lesson, the last thing we learned, that's the square root of 49 over the square root of 10. And the square root of 49 is 7. So that's 7 over root 10 is a perfectly acceptable answer. Later on in year 10, you'll learn that actually we don't like leaving surds on the bottom of fractions a lot of the time. And you'll learn how to fix that and have a rational number on the denominator of your fraction, but that's for later.